All right. Hello. This is our final project for ME372 where we had to design a jack. Um, so to start off our video here, we're going to talk about the approach that we used in our design. First, we discussed the given requirements, which were that our jack has to be able to lift at least 6 inches and hold a load of 2,000 pounds. We then chose the specific design requirements that we wanted to use in our design and started brainstorming possible geometry options. And after that, we chose our design and constructed a model in MATLAB in order to search the design space and finalize our dimensions for our jack. After finalizing our dimensions, we constructed a model in ANSYS to be able to analyze a specific part that we chose, which was the side pin, and we were able to look at the stresses and deformation that the side pin would experience during use. And afterwards, we were able to translate our final design using 3D modeling and drawings.
In addition to the 2,000 pound and 6-inch requirements, we decided we wanted to create the jack to be corrosion resistant. And so we chose stainless steel as the material to construct all the parts from. This was done because any kind of failure in the jack due to corrosion would be incredibly dangerous to any operators and could cause significant damage to anything being lifted. Additionally, we chose to use stock parts to reduce the cost of the design. This did mean that we were only able to use sizes that we found stock parts for, but this, as mentioned before, was much cheaper, and so we sourced all of our parts through McMaster-Carr. Additionally, we chose to use steel because we wanted to have infinite life and not have to worry about fatigue, again, to reduce the risk of damage to anything being lifted or harm to an operator if it was to fail due to fatigue.
In order to make sure our load, our product never actually reach its catastrophic failure, we decided to set a minimum safety factors for all of the types of failure. And then according to how catastrophic of a failure it would cause, we increase those safety factors accordingly. This was mostly just in case there was any misuse of the product, and because of the safety factors we've placed and the results we've gotten, we're very confident it should be able to operate under the recommended loads. A little bit about the optimization process we did. So we used MATLAB for all of our analysis, as well as ANSYS. We varied the inputs based off what was available to us in McMaster-Carr for the stock parts, and then we would check the results. Anything that was under the requirements that we were satisfied with, we would adjust accordingly and basically run that over and over again. And we use different plots like this figure shown on the right to help give visualizations of the available analysis.
Lastly, once our model was constructed, verified, optimized, and analyzed, we used it to create a design for a jack to withstand 2,000 pounds and can lift in the vertical direction 6 inches. SolidWorks was then used to translate our model into a tangible product that can be visualized and eventually communicated. Now, some major design takeaways that we found after completing the project was because we were using stock parts, it did require us to over-design a little bit because we would find our certain stress that the member could hold, but we'd have to bump up to the next size. On top of that, with the static analysis project in the previous step, we found that the jack would fail either by buckling or by tear out. And so we designed it to instead fail by those, to fail actually with a little bit more control. And then lastly, we did an analysis on the side pin, which was a pretty complex part, and thus solving with hand calculations would be a little difficult. So ANSYS FEA allowed us to analyze all the stresses more individually and get a more accurate conclusion. Thank you.